In this lesson, I'll show you how to graph quadratic absolute functions. The question reads, graph each of the following absolute value functions where x is an element of the reals. Now I do realize that question C is a cubic, but I've included that as an extra. Let's start with question A. We have y is equal to the absolute of x squared minus 4. The guidelines to doing this are shown right here, and in step number 1 they say graph the equation however you choose. Since this is a pure quadratic, notice that it doesn't have a first degree term. I can solve this by setting y is equal to 0. So I'll set y equal to 0. I'll bring that 4 over, that's a positive 4. And square rooting both sides gives us plus minus 2. So we have 2 points, one at negative 2 and 0, and one at positive 2 and 0. Let's go ahead and plot these. We have one over here and one over here. In step 2, they say locate the x-intercepts and vertex. Well, we haven't finished graphing, so to find what the vertex for this is, we can obviously find the average between negative 2 and 2, that's 0, and substitute that back into the equation. But I know that negative 4 is a translation downwards. So our vertex should be 1, 2, 3, 4 from the origin. In step number 3, they say change the y-coordinate of the vertex to negative. So we have to change the vertex, which is at 0 and negative 4, where I multiply negative 4 by negative 1. That makes it positive 4. Therefore, we have a point at 0 and positive 4, which is over here, 1, 2, 3, 4. I'm going to explain why I do this in a moment. And finally, in step number 4, test a random x value before and after the x-intercepts. So what I have to do is test a value that's to the left of this point, in between these points, and to the right of this one. And what you'll find is that if you, let's say, substitute negative 3 into here, you'll always end up with positive y outputs. If you test a point in between this intercept and this intercept, let's say you put 0 into here, you'll end up with 0 minus 4, that's negative, but taking the absolute of a negative number makes it positive. So anything in between these will be the opposite of what you would expect, somewhat of a reflection. None of these will exist given that it's an absolute equation. So what you see graphed is the graph of this absolute function. Now there's a reason to all of this. Of course, you don't just follow guidelines without really understanding why they're there. The reason why we change the y-coordinate of the vertex to negative is because what we're actually supposed to do, is make this part negative, because in absolute you have two versions. You have the positive version, which is the one that I solved, and there's also the negative version, like this. And if you solve this, you will once again end up with negative 2 and 2 as your intercepts. However, if you expand, you end up with x squared plus 4. X squared plus 4 has a vertex at 0 and positive 4, and that's the reason why we switched the y. Think of it as a shortcut. Now if you found that confusing, let's do another question. Let's do question B. In question B, we have y is equal to the absolute of x squared minus 2x. This is an incomplete quadratic, meaning that it doesn't have a constant, and you can solve this by setting y is equal to 0. So I'll set y equal to 0, and notice that I'm solving the positive version of the equation. Factoring out an x, we have x minus 2. Therefore, we have x is equal to 0, and x is equal to positive 2. So our point's at 0 and 0, and another point is at 2 and 0. Let's plot that. 0 and 0 is right here, 2 and 0 is right here. And the vertex for this equation is you take the average between the two x's, 2 plus 0, and divide by 2, you end up with 1. Substitute this now back into your equation. You have 1 to the power of 2, that's 1, minus 2 times 1, that's negative 1. So your point will be at 1 and negative 1. That's right here. Connecting these, your parabola should look something like this. Now, of course, it's not perfect. It's just a sketch, but just keep that in mind. Now you're supposed to switch negative 1 to positive 1. That will give you a point right here. And everything in between these intercepts should not be negative. That's because of the absolutes. So it will look like this. Now, once more, the reason for this step where you switch the y-coordinate of the vertex is because technically what you were supposed to do is solve this as if it were y is equal to negative bracket x squared minus 2x. And if you're confused about all this, make sure that you watch the linear solving of absolute functions. where we really discuss this in detail. And having solved all of this and found the x-intercepts, you would have gotten the same x-intercepts, but the vertex would have been 1 and positive 1, which is what you're seeing here. Let's move on to question C. In question C, we have y is equal to the absolute of x to the power of 3. X to the power of 3 is one of those functions that you should know by now how to graph, and it looks somewhat like this, where it crosses the origin and it goes up and down like that. Now that's what the equation looks like had this been positive. But if we were to graph the negative version, a negative 1 coefficient in front of x to the power of 3 makes it reflect about the horizontal axis. So technically you would have another graph that looks like this, where it's its reflection almost. And what you're supposed to do now is select points to the left of this and to the right of this to see what happens. So if I were to select, let's say, negative 2 and placed it into here, I get negative 2 to the power of 3. Negative 2 raised to the power of 3 is negative 8. And the absolute of negative 8 is positive. So anything with a negative y output doesn't exist. This tail end shouldn't be there. Similarly, had I chosen x is equal to 2 and substituted into here, I would have gotten 2 to the power of 3, which is positive 8. Therefore, none of this would exist. So the graph that you see on your screen, this sketch, represents the absolute of x to the power of 3. And there you have it. That is how to graph quadratic and cubic absolute functions.